Question number 5 says we have a buffer solution that contains 0.12 moles of our propionic acid. So here's our acid. We're given moles. We're also told that it's in 1.5 liters. So let's figure out the concentration of our acid. So 0.12 moles divided by 1.5 liters will give us 0.12 divided by 1.5 liters. 0.08 molar, so our acid, 0.08 molar solution. Then we have 0.1 moles of our sodium propionate, which is our base. So this is our acid, and then we have our base. We need to do our moles divided by 1.5 liters. So let's do that next. 0.1 divided by 1.5. So we get 0.067, let's do that. 0.067 molar for our base. Okay? So what is the pH of this buffer? Well, we know that pH is equal to the negative, well, pKa, we'll just keep doing that, plus the log of base over acid. So pH is equal to the negative log of our Ka. So we need to look up propionic acid here real quick. And propionic acid is 1.3 times 10 to the negative 5 plus the log of our base we said was 0.067 and our acid we found was 0.08. So let's do some calculator plugging. Negative log of 1.3 times 10 to the negative 5 plus the log of 0.067 divided by 0.08. We should get 4.81 pH. That's an acidic solution, and we started off with our acid, so that makes sense. Now let's look the pH of the buffer after we add 0.1 mole of sodium hydroxide. Well, since we're given moles here, let's write out what's happening. We've got our NaOH, so we have hydroxide. We're going to drop the Na because that's just a spectator. So we have base, and it's going to be reacting with our acid, our propionic acid. I'm just going to say HA for our acid symbolizing. And we know that our acid is going to be a proton donor. We're going to have water, and what's going to be left over? Our conjugate base. All right, so let's write down what we started with before. And let's just look at moles. We'll change it to concentration here in just a minute, but since we're given moles here, let's look at this. So before we are given, let's see, 0.01 hydroxide. Before, how much acid did I have? 0.12 moles of acid. All right, and I also had 0.1 moles of my conjugate base, 0.1. Now let's look at what's going to get used up here. Definitely the smaller one will get used up first. So we're going to subtract 0.01, subtract 0.01, add 0.01. So not going to be any of that left. So this is after. So 0.12 minus 0.01 would be 0.11 moles. Over here I have 0.1 plus 0.01, so I'm going to have 0.11 moles. Now I can look at concentration. I can look at my acid and my conjugate base concentration by taking those moles, dividing it by 1.5 liters. Okay, so let's find those concentrations now. All right, so 0.11 divided by 1.5 gives me a concentration of 0.073. I'm going to write that here. And it's the same concentration for both of these, 0.11 divided by 1.5. So both of these will have the same concentration. So I'm just going to write it once since I don't have very much room. All right, so now let's write out our Henderson-Hasselbalch equation. We've got pH is equal to the negative log, same propionic acid, the 1.3 times 10 to the negative 5, plus the log of our base over our acid, and these are both the same numbers, 0.073 over 0.073. All right, let's see what we get. Negative log of 1.3 times 10 to the negative 5 plus the log 0.073 divided by 0.073. Notice 0.073 divided by 0.073 would give us the answer of 1, right? And so we get the same as just the negative log of that. So our pH should be 4.89. And notice that we added hydroxide, we added a base, and we went from 4.81 to 4.89. So our number did increase, making it more basic, very slightly more basic. This next one, letter C, what's the pH of the buffer after we add 0.01 moles of hydroiodic acid? So we're going to do the same thing here, except for instead of adding a base, we're adding acid. So I'm going to write out that we have our H plus. I'm leaving off the iodine because that's just a spectator. But if I'm adding acid, it's going to be reacting with the conjugate base, right? So I'm just going to write A minus. We don't need to write the whole procreate. So we have H plus A, and we're going to make more acid, right? It's going to create our propionic acid. So what did we start with? We're going to write before here. It told us that we have 0.01 moles of our acid. How much base did we start with? Way up here, it told us we started with propionic, 0.1 moles of it. And how much acid did we start with? 0.12. Again, we're just looking at moles, just because they're telling me that they're giving us in moles. Now, which one's going to get used up first? The smaller one. So we're going to subtract 0.01. So after, we're going to have none of that left, minus 0.01, and then we're going to plus 0.01. So 1.1 minus 0.01, we should get 0.09 moles, right? This is all in moles. And now to get that concentration, we do need to divide it by, it was in 1.5 liters. So this will give us 0.13, and that's moles divided by 1.5 liters. All right, let's find our concentrations here. Then we can plug it into our Henderson-Hasselbalch. 0.09 divided by 1.5, so 0.06. I'm going to write that in right here. 0.06 molar, that's for my conjugate base, and 0.13 divided by 1.5, 0.087, let's write that, 0.087 for my acid. All right, now let's plug it into our pH is equal to the negative log of our Ka, which is still 1.3 times 10 to the negative 5, plus the log of my base, we said was 0.06, over my acid, which we said was 0.087. negative log of 1.3 times 10 to the negative 5 plus the log of 0.06 divided by 0.087. We got a pH of 4.72, almost 0.73, but 4.72. If we look at that, let's compare this value. So up here, our first time when we just looked at the buffer, we had a 4.81. When we added base, notice it went up 4.89, so it became more basic. If I compare my buffer, and here I added acid, it went down 4.72, which to become more acidic, it lowers the pH. So all of these make sense. All right, last practice problem. All right, this one, I noticed that it was missing a very relevant piece of information. So we have to prepare a buffer with a pH of 4.80. You have the following 0.1 molar solutions available: formic acid and sodium formate. So that's our first option. Formic acid would be my acid. The conjugate base would be the sodium formate. Number 2, we have propionic acid with sodium propionate. PROP. There we go. And number 3, phosphoric acid and sodium dihydrogen phosphate. So sodium, phosphoric, and sodium. So all of these are acids with their conjugate bases. Okay, so here are 3 different buffer solutions. We have 0.1 molar solutions of all of these. Which one should we use? Well, think about what we know. pH is equal to pKa plus the log of base over acid. And we know that when the ideal situation is that the pH is equal to the pKa. And we had an example up above where we had equal amounts of concentration of the base and the acid, which made the pH equal to the pKa. Remember when we did the negative log of 1.3 times 10 to the negative 5? We got 4.89, which is equal to, if we added the log of both of those being the same concentrations, that just became nothing. So ideal situation is when pH is equal to pKa. So we would love for the base and the acid to have the same concentration to make this happen. So let's see what these Ka values are to see what's the closest to the pH of 4.8. So I need to look up on our Appendix D formic acid, and formic acid is 1.8 times 10 to the negative 4. That's our Ka. So our pKa, the negative log of 1.8 times 10 to the negative 4 is 3.74. Let's look up propionic acid. On my appendix, propionic acid, we just used that up above, didn't we? So the Ka is 1.3 times 10 to the negative 5th. And we just did that math. 1.3 times to the negative 5th was 4.89. And let's look up phosphoric acid. Phosphoric acid, we use the K1 value, 7.5 times 10 to the negative 3. So the pKa would be negative log of 7.5 times 10 to the negative 3. We get 2.12. So we want a pH value of 4.80. Which one of these is closest with plus or minus within a pH point value? And it would definitely be our propionic acid. So this is the solution we would want to prepare a buffer with about a 4.80 pH, where our pH is equal to pKa. And last, how many milliliters of each solution would you use to make a liter of this buffer? Well, remember, we want equal concentration of our base and our acid. Remember, concentration is moles per liter. So if we have the same number of moles of each of these, which I'm assuming that we do, because we have 0.1 molar solutions, so the same concentration. So we would just want 500 milliliters of each, 500 milliliters of our acid and 500 milliliters of our base to give us 1,000 milliliters or 1 liter total. Because again, if we have the same concentration, then we take that part of the equation out and we have our pKa equal to the pH.